Hi guys, this is going to be lesson 8-6 today. It is on page 392 in your book. 392. It's going to talk about figures today. We know that a figure is a closed shape where line segments come together and it has to be closed to be a figure. Kind of like a polygon. Polygons are figures. And so they're going to talk about two types today. They're going to talk about congruent, and you have heard this word before. This word talks about anything that is exactly the same. Got my capital letters going on here. Congruent, exactly the same size and shape. It must be the same. Now, here's what they're going to do to you. They're going to flip it to the left, flip it to the right. They can flip it upside down. They can flip it however they want to. You just have to be savvy enough to know that it measures the exact, it's just sitting in a different position. And I gave you some down here, so we'll talk about that in a little bit. The other kind of figures you have are similar figures. Similar meaning they have the same shape, but they're not going to be the same size. They're going to have a proportion to each other. So you have to kind of find out you have to find out the proportion that the original shape has to the second shape. So that's going to be what you figure out today. Again, you know, this geometry chapter is more about our terms and definitions than actually the math that's going on. So some of you have maybe enjoyed the little vacation from math. Here today we have also a word is corresponding angles that you see. I underlined it here. If a corresponding, that means from one figure to the other figure, the angles must be the exact match. And here's what I mean. Over here, I drew ABC. And then right beside it, I drew triangle LMN. Now, I didn't measure these, but these are going to be the exact same size and shape triangles. So they're congruent figures. Congruent. They're the exact size, exact same. Both are triangles. I just flipped one around, okay? Now, here's the tricky part today, guys. Corresponding angles must be the exact match. And as you see here, I used the congruent sign. A is the same as L. And so here's what I mean. See how A is at the top point? Well, the top point to the other one, the other triangle, it's flipped upside down, but A is the same as L. Now, if you notice, I'm gonna sneak my hand in here. A went down to B, which is going down to the left, down and left. Now, if I go to L and I go up, the opposite, and left, well, up and right, sorry, this is M. So B is the same as M. And now if I go from C or A and I go down and right to C and I go up and left, C and N are congruent. It's the math part. This is a rule. Corresponding angles must be the exact same. If you tell me that B and L are the same angle, that's not true. That's not true. Okay? You have to find the relationship of the original to the second one. They're congruent, and then I told you what their corresponding angles was. Okay? Now, I drew two triangles down here. They're similar. Similar because they're both triangles, but they're not the same size, and that's exactly what the definition was. Same shape, but not same size. Also, again, I'm going to assume that you know this, but you're going to put all of this information into your measurement and geometry book so that you have all of these definitions to work with here. And as you can see, this would have never fit on our little index card, so that's why you have a larger book here. So I still stayed with my letters, triangle A, B, C, triangle L, M, N, except this time I took B over to the right. A, B, C, A, B, C. So A is the same as L, B is the same as M, and C is the same as N, which is what I wrote over here. And I didn't do equals, I did congruent because they're the exact same. A and L, B and M, C and N. But this one didn't flip at all, so that was easy. Now I also put numbers because it's showing the length of each side. So over in the first triangle, A to C is measuring 2 units. A to B is 3 units. C to B is 4 units. Now, as you see in my similar triangle, not congruent, but similar, they're doubled. 2 became 4, 3 became 6, 4 became 8. So these are similar triangles because I doubled it in size. Again, I just drew it and went with the measurements, but in your textbook and things like that, it would be the exact same size. Now, if you go to page 394, ooh, sorry. That's like a Humpty Dumpty moment. You had a great fall. If you go to page 394, I'm just going to go through the directions here of how they want you to answer today. Okay, it's a very easy lesson. So 6 and 7, they gave you the original. They gave you a trapezoid called ABCD over on the right, ABCD. And they gave you a little grid with the dots to act like graph paper so you can prove that it's exactly the same or that it's not and that it's similar. So if you look at number 6, if you were to twist and spin and look at it, is ABCD the same, congruent, as what they drew in number 6? And you're either going to answer with a yes or a no. Moving on to 8, 9, 10, and 11. You have MNOP over on the left as your example, MNOP. And the same thing, you're answering with yeses and nos. 8, when you look, and they gave you the measurements of the sides. Similar, meaning same shape, but not the size. As you can see, they're all rectangles, so they're all going to be similar. But are they similar with their proportions? Okay, so MN was measuring 6. In number 8, it's measuring a 5. So that's a difference of -1. Over on the side of MP, that's measuring a 3. And over on number 8, it's measuring a 2. And so that went a down 1. So if they're similar, they have to have the same shape, but not the same size. So would 8 be similar, yes or no? So that's how you're going to answer them. 12, 13, 14 is a little bit of your math today. They gave you an original PQR over on the left. And you have to look at the math, what they gave you. Angles or sides, depending on what kind of math they wanted you to think out. And so 12, you're going to have to find the meaning of x. So x is going to be a number in 12, but 13, x is going to be the measurement of the angle y. Measurement of the angle y. And then, which you're going to know, that's a tricky one. You're going to know that from the original, if you look at the original. And then 14, you're finding the value of x, and that's just going to be a number because it's the length of the side. So I want you to try 6 through 14 because I want to see if you understand the lesson before giving you your practice sheet. Obviously, you have your practice sheet. So it's just a baby step today. Do you understand this? And I can tell by your Google answers. Okay, so that is 8-6 today. I will pan out so that you can see the board. And then you can put me on pause and you can put this in your measurement and geometry book. If you have any questions, best thing is an email or else you can do a private comment. I just noticed that private comments kind of get lost. So go ahead and email if you have any questions. That's math class today, Blue. Bye-bye.